The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone, and thanks for attending this morning's webinar, Gas Rule Update. I'm Marissa Davis, and I'll be facilitating today. So this morning's presentation will be the fourth in our social distance webinar series, and the structure is going to be a little different than you might be used to. So as you know, there is a lot to cover, and because it would be impossible to cover everything mega rule in the hour time slot I've given Wally to present, he's going to give you a high-level review of the rule today. And then instead of answering questions at the end of the webinar like we normally would, I'm going to take everyone's questions and feedback, and we'll have a live Q&A follow-up webinar in 2 weeks where Wally will address all of those questions and input. So still, if you have questions throughout the webinar, go ahead and ask them through the question function on here, and then get registered for the webinar in 2 weeks. Again, we hope that you and your families are staying safe and healthy, and let's get right to it. The host of today's webinar, G2 Integrated Solutions, provides responsive support and comprehensive suite of asset integrity, engineering, GIS, field services, regulatory, and technology solutions that address asset performance through its life cycle. For more details on our services, please visit our website. And now I will introduce our presenter, Wallace Magahi. Wally is G2's Director of Regulatory Compliance. He specializes in regulatory compliance consulting, inspections, audit support, and training based on Code of Federal Regulation requirements. He is a native of Pennsylvania, but has lived most of his life in Louisiana, where he's gained experience in the petrochemical, petroleum, and pipeline industries. Wally's retired from the Femsa Office of Training and Qualifications, has over 40 years of energy industry experience, and frequently lectures at state pipeline safety seminars as well as at industry organization functions. And Wally, it's all you.
Thank you, Marissa. This morning we're going to go over the Amendment 192-125 to the Code of Federal Regulations 192. And that amendment becomes effective July the 1st, 2020, double question mark. So the rule applies to the onshore gas transmission pipelines only. And in February of this year, Femsa held a public meeting. There was a lot of material covered in that public meeting. FAQs were discussed. We did not receive any inspection guidance or protocols at that point in time. There was a lot of conversation, and no final FAQs were presented. There were draft FAQs presented, and they are out on the Femsa website at the public meetings website. Those FAQs were also introduced by the industry at that meeting. There were multiple FAQs discussed. Many of them Femsa kind of responded to during that meeting, but again, there was nothing official published out of that at this time. Inspections that are going to be done on this final rule are not, as was instructed to in that final meeting, are not going to be targeted inspections. In other words, they're not going to come out and do an inspection based entirely on this final rule, but questions associated with and inspection audit guidance will be given through the integrated inspection process and through those modules. Of course, if there are particular areas of this final rule that don't seem to be being met with compliance, you could fully expect that Femsa would come out and pay close attention to these new additions. The major provisions of the rule were driven by the Pipeline Safety Act of 2011 and other items as well, other things as well, but in particular, the 2011 Act added a 6-month grace period to the 7 calendar year reassessment interval. Many of our rules, as you know, have extensions added to them. Many of our reoccurring events that we have to do give us a grace period, if you will. This Safety Act added that 6-month grace period, but again, it's something that has to be requested. It's not automatic. The Act also provided for the requirement to consider seismicity in identifying potential threats, and that the operators have to report any exceedances of their transmission pipelines MAOP. It also requires operators of certain transmission lines to reconfirm the MAOP. Basically, this is talking about pipelines that do not have TVC records, traceable, verifiable, complete records, or were previously untested. They were grandfathered, if you will, in the beginning of the regulation. They have to determine their physical material property attributes, and the records have to include these items listed here: the segment's diameter, its wall thickness, seam type, and grade. In other words, you basically have to figure out what kind of pipe you have in the ground if you don't know already. Prior to the rules publication, integrity assessments were only done for HCAs, correct? This particular rule now adds class 3 and 4 locations and a new defined area called moderate consequence areas. And these assessments have to be done within 15 years of the rules publication, and then reassessments every 10 years thereafter. It also now requires that inline launchers and receivers on the gas transmission pipelines have a device that will indicate whether there's still pressure in the barrel, or be equipped with a door or a mechanism that won't allow that barrel to be opened if there is still pressure in the barrel, which is a very similar regulation that is also mirrored over in 195 for liquid pipelines and 195-426. On April 22nd of this year, Femsa issued a notice of enforcement discretion. The file name is Stay of Enforcement. Femsa doesn't intend to take enforcement action relative to July 1st, 2020 compliance deadline because of the national emergency that we're currently in. They're going to extend that period out to December the 31st, and normal enforcement will resume at that point in time. But that's not a get out of jail free card. It's not a don't have to do anything card. It's simply saying Femsa expects all affected operators to continue to work towards compliance, and they're going to fully expect to see your records demonstrating that you have done that. Even though you may not be able to achieve compliance by July the 1st, you're still making a concerted effort to do so. Now, the rule itself, the amendments include 191 for reporting malfunction or operating error that causes the pressure to build up and allowed for operation of pressure limiting control devices to occur for underground natural gas storage facilities or LNG facilities. This section is broken out unto itself for those two areas, and then section 10 is added for transmission lines only. You have to report that MAOP exceedance to Femsa. It excludes the gathering lines, distribution lines, LNG facilities, and underground natural gas storage facilities. So that modification to the reporting of safe-related conditions was made. Also, filing safe-related condition reports, the period of time, what has to be done now is it has to be sent to the associate administrator. That's a change. The 5 working days period is there, and the 10-day period is there for discovery and determination. Maximum allowable operating pressure exceedance is the same way, and the reports have to be filed or emailed, titled headed a safe-related condition report, or has to be headed maximum allowable operating pressure exceedance report, specifically to Femsa in that time period, to the associate administrator. Filing has to be done, has to include your operator ID now. The 8 items that are there are fairly the same, but there are some additions there talking about having to make sure we have the operator ID included. Sorry about that screen glitch. New definitions in the code also include engineering critical assessment. It's a documented process that has to be done. You have to include the operating history in your assessment, the environment the pipeline lives in, the in-service degradation that you know about, possible failure mechanisms that you know about, final defect sizes, any future operating or maintenance procedures that are going to be used to determine the maximum tolerable sizes for imperfections. So essentially, you're doing a critical assessment of the pipeline segment to determine the maximum allowable operating pressure. It's going to be a very detailed operation. It has to be very specific to the segment of pipeline that's in question. You know, it's not going to be, I don't think you're going to find a software package that you can plug the numbers into that this is going to give you an answer. You're going to have to do this specifically for the segments that you're dealing with. Moderate consequence area was added. It talks about a potential impact circle as defined in 903 based on the PIR. 5 or more buildings intended for human occupancy, and any portion of a paved surface or road. Now, the clarity for that paved surface road, including shoulders, designated interstate, freeway, expressway, principal arterial roadways, is contained in the Federal Highway Administration's Functional Classification Concepts, Criteria, and Procedures, Section 3.1. So you go there and you look at what it says in that section of the regulation, and it gives you a better definition of what it's looking for. And of course, again, this is a moderate consequence area. It doesn't meet the definition of a high consequence area. So it doesn't supersede HCA. If it's an HCA, it's an HCA. But if it's an MCA, it's going to be included based on this criteria. So the length of the moderate area extends actually along the pipeline, and it's going to go from the first potential impact circle and out through the outermost edge of any contiguous potential impact circle. Contiguous, so it's connected with 5 or more buildings intended for human occupancy. But the roadway data is going to be a challenge here. And that's a lot of the states, a lot of federal highways or databases are there. But within our states, there are some areas in the country where that data defining these interstate, freeway, expressway, or arterial roadways may be a little more difficult to find. So it's going to be incumbent upon the operator to determine that based on their own operating conditions and where their pipelines cross these roadways. Section 3.1 talks about other principal arterial roadways. For the most part, they fall into the top 3 functional classifications in that document, section 3.1. And the difference is there are usually multiple arterial routes serving urban areas, and then where there may be only a single arterial roadway serving a rural area. Class locations, you have to have records been added to class location definitions there, the section D. You have to have records that document the class location of each pipeline segment and that demonstrate how the operator determined those sections. Where you didn't have to have that record in the past or didn't specifically call it out, it now does. And what documents are incorporated by reference? There's some changes here. There's some things that were added, and there are some references added. So inline inspection systems, API 1163 was added. For ASME B16.5, for flanges and flanged fittings, a code reference was added for 607F. For 31G, for determining remaining strength, code citations 632A and 712B were added to that IBR section of the code, as well as the ANST code references were added. Section D, this whole section was reorganized, so the old numbers don't line up with the new ones. But this ANST inline inspection personnel qualification standard was added for section 493, and section H references the 192-150 and 192-493 sections of the code. And then of course the modified criteria for evaluating remaining strength, also 485, 632A, 712, 199, 933 were added as code citation, code references. What requirements apply to gathering lines? Well, this code, this regulation specifically excludes them. As we know, we deal a lot with gathering lines as transmission lines. So here we had to put the exceptions in for the sections of the code that don't apply to gathering lines. So the new regulations basically listed out here says that they're exempt from that, except those portions of the code. So the gathering lines don't have to follow this rule. Again, here the exception stating replaced or relocated or otherwise changed, except for the requirements of 67 and so on. Okay. So how to notify Femsa? Section 18 was added to the regulation. This is the notification section, and it's referenced here. You can see a multiple area of the regulation. There are places where it says if you're going to do something, you have to notify Femsa in that 90 days in advance of using other technologies. So basically 192.18 describes when you have to do that and how you have to do that notification process. And of course, any intrastate agency as well. So 67 talks about records for material properties for steel transmission lines installed after July 2020. You must collect or make and retain for the life of the pipeline records documenting the physical characteristics of the pipe, for those steel transmission lines installed on or before July 2020. If you have no records, to document the test, inspections, specifications, you must retain such, or if you have them, you have to retain them for the life of the pipeline. And for anything installed on or before July 2020, if the operator doesn't have records, you must then follow 624 in establishing your material properties of your pipeline. For 127, for pipe design records, again, basically the same thing, installed after July 2020. You must collect and make and retain for the life of the pipeline, documenting the pipe was designed to withstand its external pressures and loads. And for steel transmission lines on or before 2020, July 1st, have records to document the design and determination of design pressure. And then if you don't have records, again, you're going to follow 624, which we'll get to in a little bit. Passage of internal inspection devices. This is the one where we talk about having to design and construct and accommodate the passage of ILI devices in your pipelines if they're built in the future, except as provided in B&C, each new transmission line and each replacement pipe valve fitting or other line component. So as we go forward from this time, from July 1st, 2020, you're going to have to make sure that pipeline is designed and constructed or repaired from its replacement in with its ability to pass an ILI device. Records again for pipeline components after July 1, collect or make or retain for the life of the pipeline. Those records documenting the manufacturing standards that the devices were built to for things greater than 2 inches and with yield strengths of 42,000 PSI or X42 pipe. For steel transmission lines installed before July 1st, 2020, if you have records documenting the manufacturing standard, you must retain those records for the life of the pipeline. And then again, if you do not have records to document that, you must follow 624. Again, qualification of welders. This section was added for steel transmission lines. You have to maintain those records for pipe installed after July 1st for 5 years. For steel transmission, and for plastic pipe, same thing. After July 1st, 2021, they have to be maintained for a minimum of 5 years following construction. Inline inspection has to be done in accordance with API 1163 or ANSI ILI PQ and NACE SPO 102. You may also use tethered or remotely controlled tools, not addressed specifically in 0102, but you must comply with the sections of the NACE standard that are applicable, even though it's a tethered or remotely controlled tool. Spike testing requirements for 506 says for spike testing requirements, whenever a segment of transmission line is operated at a hoop stress at a level of 30% or more of SMICE, a spike test under this part, the test must be conducted this way. Number one, has to use water. The baseline test pressure must be specified as in the applicable paragraphs of 619 or 620. The test has to be maintained at a pressure above the baseline test pressure for at least 8 hours. But within that first 2 hours of that 8-hour test, you must spike the pressure up to a minimum of the lesser of 1.5 times the MAOP or 100% SMICE, and that spike has to be maintained for at least 15 minutes. And that must be conducted within the first 2 hours of the 8-hour test. Other technologies can be used to determine or document the engineering analysis for establishing a hydrostatic spike test. But again, you must notify Femsa, and you have to include the following items in that notification. The technology you're going to use, the data requirements, the assessment techniques, and evidence or review of all procedures by a qualified technical subject matter expert prior to doing this. And an operator must make and retain for the useful life of the pipeline any and all tests confirming the pipeline's integrity. 607 talks about pipeline material properties and attributes. This section of the code is new. Whenever required by this part, operators must document and verify the material properties of their pipeline. And the records that have to be established under this portion of the code have to be traceable, verifiable, and complete records. Must be maintained for the life of the pipeline. So the end result of this has to be TVC records as well. The values established under this section need to meet the requirements of the engineering critical analysis method described at 624C3 or the fracture mechanics requirements in 712, and they have to be maintained for the life of the pipeline as well. The pipe material properties and attributes verification. If an operator does not have TVC records, they must develop and implement procedures for conducting non-destructive or destructive tests, examinations, assessments in order to verify the material properties. Now, when do you do this? It says in here what's called the opportunistic digs, or whenever excavations occur in the following opportunities. So you're not being directed to go out and dig up your entire pipeline and verify the material properties. You're being told that when you have the opportunity to do so, you go out for anomaly direct assessments, for in situ evaluations. In other words, inside the pipe, you're going to run something, a tool in the pipe itself. Repairs, remediations, maintenance, excavations associated with replacements, third-party digs for another operator crossing your line, whatever opportunities you have to expose the pipe to get in there to be able to do these items listed here 1 through 5. And you have to have procedures to do these following things. Now, I would suggest to you that you pay close attention here, that as you determine what these things are for your pipeline, and as you establish these procedures for non-destructive tests or test or examinations or toughness tests, you determine whether or not those things are going to be done on the pipeline facility and whether or not they meet the 4-part test of your operator qualification program. You may well have new qualifications, new covered tasks being identified here. But it is up to you again to make that determination, to do that analysis when you review the task work to be done. Special requirements for these non-destructive methods using tools, procedures, and techniques that have been validated by a subject matter expert is important. The conservatively account for measurement inaccuracies using the safer numbers, if you will, the more conservative numbers, and test equipment that's been properly calibrated for comparable test materials prior to that being used on your facility. Sampling multiple segments of pipe. The operator has to define separate populations. You need to be able to go out and determine what areas that you have pipeline segments that the population of the pipe are similar. They fall into a population density, if you will, but that pipeline manufacture or construction segments can't exceed 2 years. If the dates between those manufacture and construction exceed 2 years, you cannot consider that to be a defined population under this section. So for each population defined according to paragraph E1, the operator must determine material properties at all excavations that expose the pipe. With anomaly direct examinations, in situ evaluations, repairs, remediations, or maintenance, except for pipeline segments exposed during excavation activities pursuant to 614, until the completion of the lesser of the following. So 1 excavation per mile, rounded up to the nearest whole number, or 150 excavations if the population is more than 150 miles. That's the density of the measurements that have to be made. Prior tests being done and conducted for single excavations according to this section can be counted as one sample. If the test results identify a line pipe with properties that aren't consistent, then an expanded sampling program has to be used to validate the statistical basis, where you can achieve at least a 95% confidence level that the material properties used in the operation and maintenance of the pipeline are valid. There has to be that 95% confidence level established there, and that has to be a documented process. How did you establish that? And again, you have to use you can use alternative statistical sampling approach, but again, you must make that notification in accordance with 192.18 to Femsa. And that 90-day period that you're going to wait for a response is defined in 192.18. If on day 91 you don't get a response, then you can proceed with your process, but if you get a response back in that 90 days, you'll have to act accordingly. For components of material properties under 607, you are not required to test for the chemical and mechanical properties of the components, but the verification of material properties required for non-line pipe components. So within meter stations, compressor stations, reg stations, separators, river crossing headers, etc., you're not required to test for chemical and mechanical properties, but you are for the pipeline sections of the facility. And again, for larger than 2 inches, for greater than X42 or greater pipe, and for any appurtenances, regardless of its size, if it can't be isolated from mainline pipeline pressures, which was really something that Femsa always looked for. They always wanted to, you had to account for things that were attached to the pipeline. If they were not able to be isolated from pipeline pressure, that they were considered to be a part of the pipeline facility. So, having said that, moving on to 619, there are some changes made in the MAOP process for steel or plastic pipelines. Of course, A remained the same, that statement's there, but 2I and II were added. And the table below indicates the changes that were made. So installed before November 1270, the multiplication factors that were used in the code were listed here. For installed after November 11th, but before July 1st, we can see class 1 is 1.1, 2 is 1.25, 3 is 1.5, 4 is 1.5, all which were changes from the original for the second two for 3 and 4 locations. But now if it's installed after July the 1st, the factor to determine the MAOP is going to be 1.25 for 1 and 2 and 1.5 for 3 and 4. Whether it's newly installed or whether it's converted under 192.14. Those factors are going to remain from now on. Here in this section, the maximum allowable pressure determined by the operator to be the MAOP, accounting for records and material properties and so on and so forth in accordance with 607. So if you've got material verification done, you're using those records to determine that MAOP. The requirements in A through D of this section, operators of the transmission line has to meet the criteria specified in 624, must establish and document the MAOP pressure in accordance with 624. And we're going to see when we get there in a minute what that talks about. Steel transmission lines must make and retain records necessary to establish the document and document the MAOP. Stop it, Wally. You got to quit moving that mouse around. For pipelines in operation July 1st, retain the existing records. Pipelines in operation as of July 1st that do not have records and are required to reconfirm their MAOP in accordance with, must retain those records reconfirming the MAOP for the life of the pipeline. And for pipelines placed in operation after July 1st, must make and retain records establishing MAOP. So if you got projects going on right now, and those projects are going to carry you through and after July 1st, 2020, please make sure your job boxes are maintained and up to date and all your records are coming in and all the proper signatures are there, and that you get those records and put them in your data set so that you can maintain them for the life of the usable life of the pipeline. 624 we've been talking about multiple times. Maximum allowable operating pressure reconfirmation. So operators of onshore steel transmission lines have to reconfirm their MAOP of all pipeline segments in accordance with the requirements of this section if you meet either of the following conditions. If you have records are necessary to establish your MAOP are not TVC and they exist in a high consequence area or a class 3 or 4 location, or the pipeline segments was established in accordance with 619C and the MAOP is greater than or equal to 30% of SMICE and the pipeline segment is located in a high consequence area, class 3 or 4 location, or an MCA, you must do a maximum allowable operating pressure reconfirmation. So that's all new. Now, procedures and completion dates. Operators of this pipeline subject to this section must develop and document procedures for completing all actions required by this section by July 1st, 2021. Make no mistake, that is not a date included in the state of enforcement document that came out earlier this month. You have to complete all the actions required by this section on at least 50% of the mileage by July 3rd, 2028, and complete 100% mileage by July 2nd, 2035. Okay. If operational environment constraints limit an operator from meeting the deadlines, The operator may petition for an extension. The notification must include an up-to-date plan. You're just going to say, I need an extension, please let me go out 5 more years. You're going to have to give them a plan as to how you're going to complete that work within the specified time frame that you've established. Pressure, variety of methodologies to be followed here. The maximum allowable operating pressure determination, meeting the condition of paragraph A, you must reconfirm using one of the following methods, and there are several here listed. Number 1 is a pressure test. Following the table we showed in 619 A2II. Material property records have to be there. Material property verification has to be there in accordance with the code requirements in 607 for a pressure test. Or you can do method 2. You can take a pressure reduction. You can reduce the pressure as necessary and limit the MAOP to no greater than the highest actual operating pressure sustained by the pipeline during the 5 years preceding October 1st, 2019, divided by the greater of 1.25 or the applicable class location factor found again in A2II in the table. So the highest actual sustained pressure has to have been reached for a minimum cumulative duration of 8 hours during a continuous 30-day period. The value used as the actual highest sustained pressure must account for differences between upstream and downstream pressures. So it's not just a matter of picking a high point on the chart or on the SCADA data or on the pressure record. It has to be an 8-hour period of continuous operation in a 30-day period. And then it has to meet these other accountabilities for upstream and downstream pressures in the pipeline for variances that are going to occur. Method 2 also talks about where the segment had a class location change. The pipeline where the class location changed from 1 to 2 or 2 to 3, you have to divide by 1.39 for class 1, 1.67 for class 2, 2.0 for class, and 2.0 for class 3 and 4. So you're going to take a big reduction if you do the pressure reduction method. When you don't have the material information that you need. As well, for method 2, an operator elects to use method 2 but desires to use a less conservative pressure reduction factor. For a longer look back period, the operator has to notify Femsa again. And there we are again with 192.18, no later than 7 calendar days before establishing the reduced MAOP, and the notification has to include this information. The planned duration, item E, is the planned duration at the requested MAOP, long-term remediation measures, and justification of this operating time interval, including fracture mechanics modeling for failure stress pressures and cyclic fatigue growth analysis and other validated forms of engineering analysis that have been reviewed and confirmed by an SME. So it's going to be a process that has to be followed. Method 3 talks about an ECA. You're going to reconfirm your MAOP following an engineering critical analysis. Or you're going to follow method 4 as pipe replacement. Simply because you don't know what it is, you're going to go put new pipe in the ground. Pressure reduction for pipeline segments with small impact radius, with small PIRs. You can reduce the MAOP to no greater than the highest operating pressure sustained during the previous 5 years, divided by 1.1, as long as that pressure was a cumulative period for an 8-hour period during one continuous 30-day period. Now, if you use this process, you must conduct patrols in accordance with 705 A and C, and conduct instrumented leakage surveys in accordance with 192.706 at intervals not to exceed those in the following table. So you're going to increase the number of surveys that you're going to do and patrols to accommodate this last method of reestablishing your MAOP. Method 6 is alternative technology. And again, if a new technology is out there, if something's available to you that you want to use, you found that it works, it meets some industry standards, whatever, you're going to have to notify Femsa in advance, again, following 192.18. You're going to have to ensure the results are consistent with the required corresponding hydrostatic test pressure for the line segment being evaluated. You're going to have to make sure your processes and procedures in place to conduct the tests, making sure the segment data that you have is correct Assessment techniques and acceptance criteria have been established and confirmed. And if any segment contains cracking, the operator has to estimate the remaining life of the pipeline. And of course, at the end of 624, records. You must retain the records of all these test analyses, assessments, repairs, methods that are going to be used, how those methods were implemented, and any other actions taken for the life of the pipeline. For ECA, this is a pretty detailed statement in the regulation now as to what they want done. When you conduct an MAOP recon, using method 3, using an ECA to establish the material strength and MAOP of the pipeline, it must comply with the requirements of this section. It must assess the threats, the loadings, operational circumstances relative to those threats, including along the pipeline right-of-way, threats, outcomes of the threat assessment, relevant mechanical and fracture properties, in-service degradation or failure processes, and initial and final defect size relevance. This ECA has to quantify those interacting effects of threats on any defect in the pipeline. Again, this is one of those things where I don't think we're going to wind up out here with a package that says, come do this and we'll establish your ECA analysis for you. It's going to be a pretty detailed process. It's going to require some very explicit information about the pipeline segment being reviewed. The material properties in accordance with this paragraph have to be the diameter, the wall thickness, the seam type and grade, the Sharpie V-notch toughness values based on the lowest operational temperatures as applicable. If any material properties required are not documented, traceable, verifiable, and complete, they have to be done so in accordance with 607. So you have to establish TVC records for this process to be followed. You must analyze and determine the predicted failure pressures for the defect. And you must assume if Smythe or actual material yield and ultimate tensile strength is not known or not documented, you have to default to, then the operator must assume 30,000 or determine the material properties following 607. So it's either one or the other. The ECA must analyze the interaction of defects, determining the most limiting predicted failure pressures. It must establish that the lowest predicted failure pressure for any known or postulated defect or interacting defects. Sorry about the dog next door. The beauties of working from home, right? The ECA for this process, an operator must use a previous pressure test that complied with subpart J. You may use that pressure test if you have one, as long as it met the requirements of subpart J, and predict how much the defects have grown since that date in accordance with 712. You must analyze the predicted size of the largest defects that could have survived the pressure test that could remain in the pipe at the time. The ECA assessment, to determine the defects, you must utilize previous pressure test or develop and implement an assessment program. Use inline inspection program. You may use other technologies. You may, provided those other technologies in the ECA have been notified to Femsa and they know what you're going to do and they've accepted that idea. You have to have the descriptions of the technology or technologies used for all tests, and procedures and process to conduct those tests have to be defined prior to them being done. For inline inspection program to determine the defects, the pipeline segments that might be susceptible to hard spots must include a tool that can detect hard spots. It says that the pipeline has a reportable incident as defined in 191.3 attributed to a girth weld failure, then the tool has to be able to detect girth weld defects. And inline inspection must be performed in accordance with 192.493. An operator must use unity plots or equivalent methodologies to validate the performance of the ILI tools. So you run the ILI to follow this ECA process. You need to make certain that the data that you get out of that tool is valid and it's been confirmed, and you have supporting data that says it's good information and it supports your assessment. Inaccuracies have to be accounted for in the procedures for the evaluation of fracture mechanics models and predicted failure pressures. Calling our ILI contractors into task here to make sure we're getting good information. If the process involves pipelines that contain cracking or may be susceptible to cracking like defects, The operator must estimate the remaining life of the pipeline in accordance again with 712. And of course, maintain all of these records that were done for these tests and analysis for the life of the pipeline. Now, 710 talks about the assessment of high consequence areas outside of Hcas. Onshore transmission lines with a MAOP greater than or equal to 30% and are located in a class 3 or 4 location, a moderate consequence area, if the segment can accommodate inspections by an ILI. It does not apply to pipeline segments located in Hcas. So this applicability applies to those pipelines involved in 3 or 4, class 3 or 4, or moderate consequence areas. In general, the operator must perform initial assessments in accordance with this section no later than July 3rd, 2034, or as soon as practicable, but not to exceed 10 years. You must perform a periodic assessment at least once every 10 years thereafter at intervals not to exceed 126 months. There's that grace period. Or shorter reassessment intervals based on the type of anomaly. If there's, issues found on the pipeline that says you need to look at it more frequently, then of course you would do that. And you may use any prior assessments conducted before July 1st, 2020 as an initial assessment for the pipeline if the assessment met the subpart O requirements of Part 192 for ILI at the time. And then of course, MAOP verification, integrity assessments conducted in accordance with requirements of 624 for establishing MAOP may be used as the initial assessment method. The initial assessments and the reassessments required must be capable of identifying anomalies and defects using one or more of the following methods. So we're going to use ILI, we're going to use pressure tests, we're going to use spike hydrostatic pressure test, we're going to do direct examination, guided wave ultrasonic testing, direct assessment, use of direct assessment for threats other than threat for which the direct assessment method is suitable is not allowed. So the use of direct assessment has to address the threats of external corrosion, internal corrosion, stress corrosion, cracking, or any other technology, again, after notifying Femsa through 192.18. The assessment method, the operator must analyze and account for the data obtained using personnel not qualified by knowledge, training, and experience. Make sure, as we've seen in the past in enforcement actions that Femsa has used in the past, when language like this is used in the code, personnel qualified by knowledge, training, and experience, I would suggest to you that outside training done, degrees, engineering degrees, etc., are certainly countable, can be considered, but you must include your own processes and procedures in that training and experience. So make certain that those folks doing this work for you have been trained in your processes and your procedures, and you deem them qualified to do the work for you, besides the outside education that they may have received. Discovery of a condition occurs when an operator has adequate information about the condition to determine the condition presents a potential threat. You must promptly, but no later than 180 days after conducting an integrity assessment, obtain sufficient information about the condition to make the determination. Much of this language is the same. The operator must comply from remediation with 192.485 and 711 and 713 if a condition could adversely affect the safe operation of the pipeline. In an analysis of that information, you must account for all available relevant information about the pipeline and complying with this requirement. Applicability of 712, predicted failure pressures. Operators of steel transmission must analyze anomalies or defects to determine the predicted failure pressure at the location of the anomaly or defect and the remaining life of the pipeline segment at the location of the anomaly or defect. You must use a suitable remaining strength calculation, either B31G, R-string processes, or an alternative equivalent method of remaining strength, provided an equally conservative result is reached. Crack and crack-like defects have to be considered and must determine the predicted failure pressure and pressures using a technically proven fracture mechanics model. And again, this is going to be at the location where the condition exists on the pipeline. Crack and crack-like defects also, the fatigue analysis must be performed using an applicable fatigue crack growth law. and they have to be evaluated by an SME. You must calculate the remaining life of the pipeline, determining the amount of time required for the crack to grow to a size that would fail at MAOP of the pipeline. When calculating cracks that would fail at MAOP and the material toughness is not documented, traceable, verifiable, complete, the same V-notch toughness value established in paragraph E2 must be used. Initial and final flaw size has to be determined using fracture mechanics. And the operator must reevaluate the remaining life of the pipeline before 50% of the remaining life calculated by this analysis has been expired. So you must determine and document if further pressure tests must be done, and you must continue to reevaluate the remaining life of the pipeline before 50% of the remaining life calculated and the most recent evaluation has expired. In other words, you got to keep looking at it. You can't do it. It's not a one done event. And you have to calculate the largest potential crack size defect using the pressure, the methods in paragraph D1. And following these Sharpie V-notch toughness values based upon minimum operational temperatures of a full-size specimen. And then, of course, the description here for the toughness values, comparable pipe, determine the toughness based on material properties, so on and so forth. An operator must explicitly analyze and account for uncertainties in reported assessment results. So anything that's there that is not normal, anything there that is outside the boundaries of a normal condition. Once we've established the detection thresholds, probability of detection, probability of identification, those things have to all be considered by whatever method you're going to use to do the analysis. And it must utilize pipe and material properties that are documented in TVC complete records. And again, not TVC, go back to 607. In performing the analysis, you must use the data as follows. Until documented material properties are available, you shall use conservative assumptions as follows. For material toughness, you have to do one of these items listed here. The Sharpie V-notch toughness values from comparable pipe, toughness values to determine toughness based upon ongoing material property verification process, and so on. So I mean, there's 5 different items here listed that you can follow to get these results. In performing the analysis, you must use the data as follows. Material strength. You have to assume one of the following material strength values: the grade A pipe 3000 psi, or the SMICE strength based on the basis of the current maximum allowable operating pressure. Pipe dimensions and other data. Until the pipe wall thickness, diameter, other data are determined and documented, the operator must use the values upon which the current MAOP has been based. Review analysis must be reviewed and confirmed by an SME. All records in accordance with 712 have to be maintained. An operator has to keep for the life of the pipeline the records of these investigations, analysis, other actions taken. Records have to document justifications, deviations, and determinations made for the following as applicable: the technical approach used for the analysis, the data used, pipe and weld properties, procedures followed, evaluation methods, models, direct in situ examination data. There's only 19 of them. Hang on, we're going to get there. Inline inspection tools, pressure test data, in the ditch assessments, all measurement tool assessment and evaluation, accuracy specifications, tolerances, all finite element analysis results, pressure cycles to failure, and predicted fatigue life, predicted failure pressures, safety factors, reassessment time intervals, data of the review, confirmation of the results by qualified technical subject matter experts, and approval by responsible operator management personnel. Just those 19 items and you're done. 192.750 talks about launcher and receiver safety after July 1st, 2021. This is the gotcha regulation like they have in 195. If someone on your pipeline after July 1st, 2021 is injured operating a launcher or receiver barrel because there was pressure in the barrel, you have no excuse. You must have a device capable of safely relieving pressure in the pipeline barrel before removal or opening of the launcher. So it has to be such that they can see the pressure in the barrel and know it's been relieved, or there's a device that will prevent the opening of the barrel or the closure if there is still pressure there. Last item in the rule update, OQ. Now, why is it here? Well, it's because 192.18 has now been listed with the operator qualification rule, but I still will suggest to you that your OQ departments do a good assessment of this new regulation and determine whether or not any new covered tasks are being identified here that will cause you to have to increase or qualify personnel to do that work. 909, how can you change your integrity management program? Again, you're going to use 192.18. I would suggest to you that you're probably going to make changes to your IMP program because of this rule. If you make a substantial program effect, significant modifications, then you must notify within 30 days after adopting the change, notify Femsa. How do you identify potential threats in the pipeline integrity system? Time-dependent threats, you must analyze and account for whether cyclic fatigue or other loading conditions, including ground movement, suspension bridge, other threats, covered segment could exacerbate cyclic fatigue. Prioritize the integrity baseline assessment. Monitor operating pressure cycles, but at least every 7 calendar years, not to exceed 90 months. Determine if the cyclic fatigue analysis remains valid. You must consider seismicity. Now, unlike our roadway consideration for moderate consequence areas where we were given the federal highway data to use, for seismicity, we're really not given a whole lot of information. There's a variety of things that we can use to determine whether seismicity is a threat to our pipeline. We can use manufacturing construction defects. If any of the following changes occur in the covered segment, an operator has to prioritize the covered segment as a high-risk segment. The segment has experienced a reportable incident due to an original manufacturing-related defect. Need to chase that down, figure out when the construction, installation, or fabrication-related defects may have occurred, when the manufacturing defect may have occurred, making sure that the analysis is done properly and account for the results of any prior assessments. As well for ERW pipe, if the covered segment contains low-frequency ERW pipe, lap welded pipe, pipe with longitudinal joint factor less than 1, other pipe that specifies a condition in B318S, pipe has experienced seam failures, including seam cracking, selective seam weld corrosion, right? Operating pressures, increased over maximum operating pressure, experienced during the preceding 5 years. The operator must select an assessment technology or technology with a proven application capable of assessing the seam integrity, seam corrosion anomalies. So quite specifically for ERW pipe or lap welded pipe, you have to do an assessment to determine whether or not that threat exists, and an assessment tool that will allow you to determine whether or not that's a threat to your pipe. And for cracks, you have to evaluate and remediate as necessary all pipeline segments, both covered and non-covered, with similar characteristics. You have to establish a schedule for evaluating and remediating those anomalies as necessary, and for segments that are consistent with the operator's established operating and maintenance procedures for testing and repair. 921 talks about a baseline assessment. An operator must assess the integrity of the line pipe at each covered segment, the internal inspection tool or tools capable of detecting those threats. Right, an operator must select a method or methods best suited to address the threats identified. So the use of internal inspection tools is appropriate for threats such as corrosion, deformation, mechanical damage, cracking, crack-like defects, hard spots, to which the covered segment is susceptible. Pressure tests, you select the method or methods best suited to address the threats. Pressure test may be the best method to assess the threat. A spike hydrostatic pressure test, excavation, in situ direct examination are methods to do the baseline assessment. using guided wave, using direct assessments, any other technology. Again, once notified to Femsa. Baseline assessments for the segments with a reconfirmed MAOP integrity assessments conducted in accordance with the requirements of 624 can be used as that baseline assessment if you follow that path. Now, what do you have to do to address integrity issues? Temporary pressure reduction has to be taken. Long-term pressure reductions can be taken. And additional preventative and mitigative measures, you can determine that the outside force is a threat to the integrity of the covered segment. Seismicity of the area, you have to take measures to minimize the consequences to the covered segment, including increasing the frequency of aerial, foot, or other methods of patrols, adding external protections, reducing external stress, relocating the line, or inline inspections with geospatial and deformation tools. So again, this seismicity issue is something that you're going to have to deal with. Continual process of evaluation. An operator must select the method or methods best suited to address the threats. Using ILI tools, performing inline inspections in accordance with 493. Select a tool or combination of tools capable of detecting the threats of your pipeline. Analyze and account for uncertainties in the reporting results. Pressure tests can be used, spike tests, excavation in situ direct examination, guided wave, direct assessment, other technologies, or confirmatory direct assessments can be used. And of course, the reconfirmation assessment and integrity assessments conducted in accordance with this requirement may be used. If you did 624, you can use that as a reconfirmation assessment. Required assessment intervals. The maximum reassessment interval by an allowable reassessment is 7 calendar years. And you may request a 6-month extension of that 7-year period. And you must do it in accordance with 192.18. If you establish that reassessment interval greater than 7 calendar years, you must within 7 calendar years conduct a confirmatory direct assessment of the covered segment, and then conduct a follow-up reassessment at the interval the operator has established. Pipeline operating below 30% SMICE, the maximum reassessment interval again is 7 years, and you can again request that 6-month extension. You can do reassessment by pressure test. You have to establish that reassessment by at least one of the following. The pressure test, again, can be done. And last but not least in our discussion, as we're winding up here with a few minutes left, 192.12 was modified at the same time in March. It became effective March 13th of 2020 for the underground natural gas storage facilities. The biggest thing here is the new regulation does not contain any language about the mandatory, non-mandatory language in the standards. So they are as they are written. If you have a solution mined salt cavern constructed after March 13th, 2020, it has to meet the provisions of API 1170 and Section 8 of 1171. If you have a solution mined cavern that was constructed between July 18th, 2017 and March 13th, it again has to meet the provisions of 1170 of this section and Section 8, applicable to the physical characteristics and operation of the facility. And if you have a salt cavern, solution mined salt cavern constructed on or before July 18th, 2017, you have to meet the provisions of 1170 and Section 8 of 1171 and paragraph D of this section by March 13th, 2021. For depleted hydrocarbon aquifer reservoirs and aquifer reservoirs constructed after July 18th, 2017, you have to meet all the provisions of 1171. And if you have such a facility, hydrocarbon reservoir or aquifer, constructed on or before July 18th, 2017, you have to meet the provisions of 1171 incorporated by reference, sections 8, 9, 10, 11, and paragraph C of this section by January 18th, 2018, and must meet all provisions of paragraph D of this section by March 13th, 2021. So there's some old dates in there that are still holding true, right? And procedure manuals must be prepared and followed for each facility. One or more manuals of written procedures for conducting operations and maintenance, emergency preparedness and response. And you must keep those records necessary to administer such procedures and review and update these manuals intervals not to exceed 15 months, but once each calendar year. And you must have those written procedures in place before commencing operations or beginning an activity not yet implemented. Again, integrity management, you must have a integrity management program for each of your underground storage facilities. It must consist at a minimum of the framework developed under API 1171 and Section 8 of the risk management for gas storage operations. It must include the following elements. You have to develop and implement the program element to meet the requirements of this section, an outline of the procedures to be developed, the roles and responsibilities of the staff, a plan for how the staff will be trained, timelines for implementing each program element, including the risk analysis, and a plan for how to incorporate information gained from experience into the integrity management program. And this program, the baseline risk assessment intervals no later than March 13th, 2024. Each operator must complete the baseline risk assessment for all reservoirs and caverns. And no later than March 13th, 2027, you must complete a baseline risk assessment on all wells. The integrity risk assessment interval must determine the appropriate interval for the risk assessments under 1171, subsection 8.7.1 and paragraph D. The reassessment for each reservoir and well must not exceed 7 years from the date of the baseline assessment. And ladies and gentlemen, I believe this is the last slide. And again, you must establish and follow those written procedures to carry out your program and must maintain for useful life of the facility records demonstrating compliance with paragraph D, including records to develop and use in support of any identification, calculation, amendment, modification, justification, deviation, determination made. And we are right there about 2 minutes overdue. But if you have questions, please submit those questions. We will address those in 2 weeks.
Yep.
Other than that, ladies and gentlemen, I'm done.
Thank you,
Thank you so
Wally.
much for your time and attention.
We hope you guys enjoyed the presentation. Assuming that I set it up right, this is the first time I've done this. When you close out the webinar, you should, a question should pop up. If you would please take just 1 second to fill that out. It's only one question, and it would be really helpful for us to know what to cover in the follow-up webinar on May 12th. If you haven't already, go ahead and get signed up for that one. I'll include a link to register for that email or for that webinar in the email that I'll be sending all of you later on today with a copy of the presentation and a link to the recording. So be on the lookout for that. We appreciate you guys coming, and we'll see you next week.